In this video we're going to have a look at a couple of input demos in terms of capturing initially single touch input and then having a look at how we can capture multi-touch input. We're building upon the demo classes that were sent out, so that's going to be our initial starting point. So we might as well kick off. I'll show you the demo first of all. So inside this one here, it is within our Java folder, input. And there's a few things within this in terms of accelerometer or key tests, but we're not going to explore those. You can explore those yourself if you wish to. We'll start off here with our single touch test. The activity just simply creates a fragment, so all the interesting stuff is contained within the fragment. So it's going to be this particular class here. Now I will run it and we'll have a look at what the thing actually does, and then we'll delve into the code. The reason we're looking at single touch first of all is really using this as a staging point to go on to explore multi-touch. It depends on the game, but for quite a lot of games we're going to assume we have multi-touch. The single touch will nicely build upon that to provide multi-touch. That's a good starting point. So we're going to go and we'll click on our single touch test up near the top, and it then fires up this particular layout where we have a text area at the bottom saying touch here. So if I were to touch this, so there I'm pushing the mouse down and now releasing the mouse. Now I'm pushing it down and now moving the mouse, and you can see the location being displayed at the top. We have a move start. If I stop and release, we have a move end, so it's detected that the end of the mouse drag has occurred, and we have an up event. And you can see in the window at top where we have down, up, down, move start, move end, and up. We're given the location at which that particular event was detected. It's measured in terms of pixels, as you can see going across. And depending on some of the values, you can see, for example, that they are 173.9, 244.4. This ties into the device. Sometimes on the device you can have some pixel accuracy or in terms of resolution for the detection of it. It really just depends on the device. But basically it's a simple single touch. I can touch it, I can pick and detect a few different types of touch events. So we'll have a look at the code that brought that about, and it is within our single touch test fragment, which is a type of fragment itself. So we'll quickly scan down through the class just to see what's within it. There is only really one area that's of relevance to the touch input. So we have our onCreateView method, and inside this we will be inflating the chunk of XML for this particular demo. So if we have a look at that, it is single touch test fragment, and open this one up. And there you can see within this here, the layout, we have linear layout. We've got a text view up at the top, and a second text view underneath that. This is for holding the X and then the whatever X value we've detected. Two more text views for holding the Y and the Y value. We have a scroll area, so if I'm moving the things about, then they will be scrolled within that area. And we've got a text view down at the bottom that I can click on. That's the one that detects the input events. And anytime I want to detect events, I detect them in relation to a particular view component. So in this sense, in our code, we're going to have to go to this text view here, the one we call single touch test event touch area, giving it an ID, and attach a TouchListener to it. And I could attach a TouchListener to any of the other ones if I had wanted to, for example, in terms of the text view, but I'm not interested in detecting touch events on that one. So we go back to our code. So we are inflating that particular view. That's simply what's displayed on the screen. We're then getting out the touch area. So this is finding the single touch test event touch area, which was that text view we had down at the bottom. So we're getting that out, and for any view, anything that can be displayed on the screen, we can we can set on it a touch listener. So a view has a method where it enables you to add a touch listener in. This will be a callback class, so that if a touch event is detected for that particular view object, then the event gets passed off to our handler, if we have specified one, for it to be processed. So that's what we're doing there. So we're saying for the touch area, we want to add a new touch listener, and it's our new single touch listener. So that's going to be a class we've created below, and that's where the interesting thing will happen for this particular demo. So there's the class there. It's just for sake of doing it and keeping it simple within the demo, as a private class within this here. We'll have a look at that one in a second. But in terms of the other things that we have within this, we have a few things there in terms of a string builder for building up our event details. We have a little method for displaying the touch position, that if you give an X and a Y value, it will retrieve the appropriate text views and then set their values to the appropriate X and Y value. Another method for displaying the event strings, using a bit of string building just to concatenate what the most recent message or event is. So that's fairly routine stuff. Now, the actual listener itself. So it's a single touch listener is what we've called it. It implements OnTouchListener. So OnTouchListener is the interface to it, and if we have a class that implements that, then we can add that or set it up as the touch listener for any particular view object that we fancy. Inside this, we are going to remember the last type of event that we detected. The reason for this, because this is really using the notion of input polling, where you will go through this and you will sort of check different things at different points in time. Now, what I'm looking for here is a change of event, where when I start dragging the mouse around, for example, it's going to be generating lots of mouse movement events as part of that drag. But I only want to signify this end point and the start point. Now, that's only from the point of view of the demo. Quite often, if you were doing fancy gesture recognition, you actually would want to track the full duration of the movement and have a look at how the thing moves around and how it interacts, or otherwise gets involved. The method where all of the magic happens is the OnTouch method. This is the one that will get to be called whenever a touch event is generated. So it's a callback method. So OnTouch, it passes in, I didn't scroll it up. It passes in the view object that received that touch event, and it passes in a motion event class that tells us what type of touch interaction happened in that event, and returns a boolean, true or false. Now, it's true if we have consumed that particular touch event. So we receive it, we look at it, and we go, yes, we can process that. Then we will return true, saying you don't need to do anything more with that event. It effectively has been processed. If we return false, what we've basically indicated is we've got it, we've had a look at it, but we can't process that touch event, so it's there potentially to be passed up to any other touch handler in the chain. Now, within the OnTouch event, the first line we do is we go to event GetActionMast, and this is a method that's going to take out, give us a numerical value telling us the type of event that happened. Now, the GetActionMast method, this makes more sense in relation to a multi-touch event. In a multi-touch event, you can have multiple different events happening on a particular frame. The GetActionMast method basically says, okay, just assume it's a single touch setup, give me the most significant event that's happened, and that's what I'm going to use. And we get it returned as an integer, which we can compare against a number of different integer codes. We can also go to the event and get the X and the Y location that is associated with that particular motion event, or the touch event in this case. So we're retrieving the type of event and the location at which it was detected. We're then displaying the touch events, we're updating the position on the screen, and we are then doing it's an if here that if we have a change in the touch event, so for example, if it was a touch detected and a touch released, that would be a change, whereas if I was dragging it in one frame, I'm still dragging it in the next frame, I'm not going to do anything about it. So it's only if I have detected that a new or a change of the status, the event status has occurred, then I'm going to do something. And I switch the event type, And there's a number of these. So motion event, you can actually have a look at the concatenated form. But within this here, action button press, action button release, cancel, down, hover, point. So you can see that there is quite a lot of different types of motion events that can be detected. We're assuming it's a touch-based one. The only ones we're interested in are action down, where you detect a touch event happening. Action move is where you detect that we have not only a down event, but it's been continued to press down and the touch event is moving, so you have a drag effectively. And if we have an action up, we've got a little bit of logic here that checks to see if we were previously moving. So if we had been moving and then we lift our finger up, that's notionally the end of a move or a drag request. If that's and alongside that, we also display that we have an up event detected. So again, we see we're interpreting the meaning in a simple way of the different events that we detect. But at the end, we just simply remember what was the event we had for this particular event handler. And we return true, indicate that we have consumed that particular event. So it's reasonably straightforward, reasonably simple. There's not really much to it. You basically register your touch handler. You will have a motion event being generated anytime you have a motion event associated with that. And it's up to us then within it to go through that, to parse it and to take out whatever useful information we want. Now that's a single touch listener. We can now have a look at a multi-touch listener. And there's a multi-touch test fragment here. So this is the sort of an extended version of it. Now I can run it. I'll show you it. Already was running over here. I'll show you what it looks like running. Now the problem with the emulator, the built-in ones, is at the time of recording this, they don't support multi-touch. So if I do my multi-touch test and let that fire up, I've got again a touch area at the bottom, and at the top I've got my X and my Y locations. And I can click on this, and if I move around, so I'm dragging the mouse around that environment, lifting it up, down and up, so I'm detecting the same types of events that I had before, except in terms of moving them around, you can see there's a whole list of zeros at the top, and there's only the first one that's been detected. So that's my touch event 0. If I had multi-touch and I could apply 2 fingers to this, for example, then the first 2 columns would be populated and have their own independent positions. But because the emulator only supports multi or single touch, we can't unfortunately demonstrate that. But if you're on a real device, you'll be able to see for yourself in the demo how it works. Right, now let's have a look to see how this works. There's a little bit of complexity to this, and it comes under the notion of you get an array of touch events, you have pointer IDs, and just trying to differentiate between the two. And I'm going to talk you through this a little bit. It's a small demo, because this is the one thing that can be a little bit confusing with multi-touch events. So we want to imagine a scenario where each frame, if I say, give me the events that happen, I will get an array that comes in that holds all of the different touch events that have occurred. And to help me differentiate one event from another, I get a pointer ID associated with each event. And the pointer ID, effectively, think of it as a pointer as in a digit. It's the thing that touched in the screen. So here I have a situation where I have one touch event occurring on the screen, and over here I've got some information detected on that. So if I were to go to my event, there's a method called getPointerCount, and it tells me the number of touch events that I have within this. This point in time is only 1, and if I were to extract that, I will find that it has a pointer ID, actually starts off with 0, but I'm just going to assume 1 here for saying the first one. So pointer ID of 1, X and Y location 100, so we're assuming here that 00 is the top left of the screen. So 100 to the right and 400 down. That's the location that a touch event happened at. But pointer ID 1 is the relevant bit. It is the first detected touch event. Now, let's assume that we progress things on ever so slightly. And we're looking here about multi-touch. So I touch another digit to the screen. In this case, if I get my pointer count, it's going to tell me there's 2. And I will get an array of 2 touch events. If I go through that array, and the first item in that array is going to be saying, oh, it's pointer ID 1. This is the old touch event. It's still touching the screen. So pointer ID 1 is the one that it refers to, same one we had before. X location is still 100 before 100. We're assuming we haven't moved it. But now we have a new event, a second touch event being detected, and we're given that pointer ID 2. And we're saying it's 300 by 200 across. So you can see there that now we have 2 different touch events, and our pointer ID is the mechanism whereby we can differentiate and distinguish one from the other. Let's move things on ever so slightly. So in this scenario, I have removed the first finger I touched against the screen. The second finger that I touched is still touching the screen. So we're ending up in a situation where I only have 1 touch event. So you see when we do my get pointer count, it's going to say that I have 1 single point of touch, but the pointer ID in this particular case is going to have a pointer ID of 2. So it's not 1 because it was the second one, so it is persistent. So as long as I touch the screen with a particular one, then this one will be retained throughout the duration that it touches. So the pointer ID, as long as you have something touching the screen, never changes, is always the same for that, the duration of that touch event on the particular screen. And again, still position 300 by 200, we're assuming we're not moving it. And if I were then to go along and I still had this, which was the second digit that touched the screen, and now I come along and I put down another digit. So you can see in this case, the pointer count would be 2. We have 2 points of contact. If I look at the first item in that array, it's going to tell me that it's pointer ID 2, so it's our old favorite one that's been there for some time. And the second one in the array, this is the newly detected event. So when it's newly detected, it has to give it a pointer ID that's not currently used. So pointer ID 2 is currently used, but pointer ID 1 isn't currently used. So it's our mechanism whereby we can differentiate between the two. So that's the only, it's not really that confusing, but it's the only thing we have to bear in mind, that whenever we're accessing this particular setup, we do have to take into account which particular pointer ID we are dealing with. So if we come back to our code, this is the type of thing that we're going to see within this. So we have our onCreateView method, and it's simply going to inflate the layout. So in this case, it's our multi-touch test fragment. And within this here, we have a few things at the top for our linear layout for the X locations, and then a list of X locations we're detecting for the Y locations, and a list of the Y locations that we're detecting. We've got our scroll area for displaying the events that occur, and then we've got our text view area, which is our multi-touch test event touch areas. That's the thing that we'll associate our listener with. So back over to this one here. This simply inflates it, takes out that particular touch view, and then sets a new listener on that, our MultitouchListener. And down here we will have our MultitouchListener. Again, implements OnTouchListener. It's the same type of listener, it just does multi-touch. This one's a wee bit more fancy. We'll scroll down just to say at the bottom we've got our usual display methods for displaying the event locations, or for displaying the actual event itself. So these things will appear down at the bottom. Now, the OnTouch event, if we have a look at it here, actually before we do that, we'll go up to the top of this here. So our MultitouchListener. Because it supports multiple touches, we need to update this here so that we are potentially remembering multiple pieces of information. So I'm defining that at most I will remember up to 20 simultaneous touch positions. So I mean, good luck trying to exceed that in terms of a particular device screen. So we have a maximum of 20 fingers touching the screen at a point in time. And we will then have, similar to the last one, we're remembering the last type of event and the location of the event, the X and Y location. Except now we have an array of 20 of these for the different types of touch event that can occur. For the OnTouch method, for this one here, we've got a view, again, same one as before, and we've got the motion event that occurs for our OnTouchListener. And again, Boolean is returned, true or false, depending on whether or not it is consumed or not consumed. For the event type, over here, we're getting out the same thing as before, so we're trying to work out what new type of event has occurred in this particular frame. So this simply detects, if you like, the most significant change for that frame. And we're also taking out the pointer ID associated with that event. Now, so this is going to the event. We are getting the event GetAction index. So that will give us the index of the event, if you like, the change for this particular frame, and we're getting the pointer ID associated with that event. So long and short, this will tell me what event has happened. If you've got a push, press down, a release, a move, and the pointer ID will get me the pointer, which digit, if you like, what identifier are we using to link to and associate it with this particular value. So having detected that, we then have the list down here. So we go through the different types. So again, if we have to compare it, if we have a change for that particular pointer ID, so the new event that's been detected in this frame, if it is a different type of event for the pointer ID, then we're doing exactly the same type of stuff as we did before. We've got stuff for action down, for action move, and action up. You'll notice that there are a couple of options under this now, so that for motion event action down and action pointer down, in both cases we are displaying down itself. So as to what these things are for, action down, it is the motion event that occurs for the first detected touch on the screen. And the action pointer down is where you get that particular one if you have multiple touches of touch points on the screen. So it's slightly confusing, but basically both of these arise whenever something, one digit, could be one or more digits, have been pressed down on the screen. Action move, same thing as before. If you have multiple or ones, we'll have a move event on it. And if I release my finger, if action up, it'll be true if it's the last one. Action pointer up will be true if I already have something and multiple points in the screen and I've released one of those points in the screen. But in both cases it occurs whenever you have an event being raised up. So there, all I'm doing is I'm updating the things, displaying it out, and that's about it. The bit down here is probably the one that's quite relevant then for a game. So what I'm doing is I'm getting my pointer count. So this will tell me how many touch events I actually have on the screen. And I am getting the pointer ID associated with each of those different pointer counts. So if I have an array of 5 of them, I'll go through the array and I'll get the pointer ID for the touch event at the start of the array, and then the next position in the array all the way through to the end of the array. And as remember, we need that because the pointer ID does not necessarily correspond to the array position. If I get the pointer ID, I know which type of thing I'm dealing with, so then I can go to my array of 20 different touch events, and I can, in this case, all I'm doing is I'm storing the X and Y location. And within a game, you would probably then be checking to see whereabouts it is it in any particular region on the screen, do you want to do something with it? So it's reasonably straightforward in terms of how it works. Not really much else for us to talk about in terms of this demo. It's worthwhile going through this a few times to get your head around it, but when you do, it's going to be reasonably easy to use it within your game.